So dear students, in this video lecture, we are going to see questions related to the concept of alloys. So alloys are mixtures of solid components. So we have been looking at questions where liquids are mixed. So here, what is alloy? Alloy is basically mixtures of different metals. So basically the same concept of mixture will be applicable here. So let's have a look at the questions. So we will learn the concepts from the questions itself. So let's try to solve a few examples. So let's take the first example. Two alloys contain zinc and copper in the ratio 2:1. So let's name the alloys A and B. So in A, zinc and copper. So zinc and copper ratio is 2:1. In alloy B, this ratio, that is ratio of zinc and copper, is given to us as 4:1. Now the question is, in what ratio should you be mixing them so that the final result that you get contains zinc and copper in the ratio 3:1. So you can solve these kind of questions using the crisscross method of alligation as well. Now if I ask you what is the percentage of zinc here, so 2 out of 3 parts, so you would say 66.66% zinc. What is the percentage of zinc here? So 4 out of 5 parts, so that is 80%. What is the percentage of zinc here? 75%. So if you apply the alligation method, crisscross method, you will immediately find the ratio. So what is this? This is 5. 66.66 is 66 2 by 3. So you can say 66 2 by 3. So this is 5. What will this be equal to? So this is equal to 8 1 by 3. So that is equal to 25 by 3. So the ratio is 5:8 1 by 3, which is 5:25 by 3, or 15:25, which can be written as 3:5. So this is the correct answer. Now let's take another example. An alloy of copper and zinc contains copper and zinc in the ratio 5:3. So here copper is 5 parts and zinc is 3 parts. So copper is to zinc. So if you see alloys A and alloy B, so in alloy A, percentage of copper is 5 by 8, or you just let it be proportion of copper 5 by 8. So what is proportion of copper in alloy B? 1 out of 8 parts. So you are thinking that in what ratio should I be mixing them to achieve what? Equal proportions of copper and zinc. Equal proportions of copper and zinc means in the ratio 4:4 or 1:1. So 4 out of 8 parts of copper is what you want in the resultant. So apply the crisscross method here, you will get the ratio. So all these 8s will get cancelled. So difference of 5 and 4 1, difference of 1 and 4 3. So the ratio is 3:1. So let's see this one. A and B are two alloys. So A and B are two alloys of gold and copper. So gold, copper, and B also contains gold and copper. So here the ratio is 7:2, whereas here the ratio is 7 by 11. Now what is being said? If equal quantities of the alloys are melted, equal quantity. So let's make the quantity equal. 7 plus 2, 9. 7 plus 11, 18. So take the LCM of 9 and 18. So the LCM is 18. So you can assume that you are taking 18 units of A and 18 units of B. So what is the significance of choosing 18? Because 18 is such a number which can be divided in the ratio 7:2 as well as in the ratio 7 and 11. So now let's understand how much gold and how much copper. So gold, copper, gold, copper. So in the first alloy, you have taken 18 units. So how much is gold? So 7 out of 9 parts. So 14, 4, similarly 7 and 11. So if you combine these two mixtures or these two alloys, you will get a third alloy. So in that third alloy, how much is gold and how much is copper? So gold is 14 plus 7, 21. Copper is 4 plus 11, so that is 15. So in the resultant, this is the ratio of gold to copper, 21:15, which is equal to 7:5. Now let's have a look at this one. 40 kg of metal contains 1/5 copper and rest zinc. Another 50 kg of metal, it should have been alloy instead. So let's consider we have two alloys. So 40 kgs of alloy A and 50 kgs of alloy B. So 40 kgs, what is being said? 1/5 is copper and the rest is zinc. So how much is copper and how much is zinc? So 1/5. So 1/5 of 40, that is 8 is copper and the remaining, that is 32 is zinc. What about alloy B? In alloy B, 1/6 is copper. So 1/6 is copper, that means 50/6 is copper and rest is zinc, that means 5/6. So 250/6 is zinc. The ratio of copper and zinc into the mixture of these two metals. So if you mix them, what will be the final ratio of copper and zinc? So final ratio of copper, 8 from here and 50/6 from here. So 8 plus 50/6, how much zinc? 32 plus 250/6. So I think 6 will get cancelled. So 8 6 are 48. 48 plus 50, 98. So 6 getting cancelled. So 32 into 6. So 192. So 192 plus 250. So 350. So 192. So 442. So 98:442. This can be simplified. 49:221. So this cannot be simplified any further. So answer is 49:221. Let's see this one. Alloy A and B comprise of two metals, copper and zinc. Alloy A and B. So alloy A has copper and zinc in the ratio 3:5. In the ratio 3:5. So if somebody asks what is the proportion of copper, so 3 out of 8 parts. So concentrate on any one element. So copper. So in alloy A, 3 out of 8 parts are of copper. We have no idea about alloy B. We have no idea what this ratio is. Copper out of total. So this represents copper. This represents total. We have no idea what this ratio is. But we know that the resultant is in the ratio 3:1. No, these are mixed in the ratio 3:1. So if you apply crisscross method, the ratio is already known, 3:1. The resultant alloy has copper and zinc in this ratio, 37:59. So if you talk in terms of proportion of copper, So 37 parts out of 96 parts. So 37 out of 96. So if you are able to figure out this number, then you can easily say that out of a total of how many parts, what part was of copper. So we will get an idea about alloy B. So this is the question. Fine. Now try to make 96 everywhere. So 96 in the denominator. So instead of 3 by 8, if you multiply this by 12, so this can be written as 36 by 96. It's the same thing. It's the same thing. So let me assume here the answer is n by 96. So if you are able to find the value of n, the nature of the alloy will be decoded. So let's do that. Let's remove all these 96 from here, because difference, if you take the difference and then you take the ratio, this 96 is going to get cancelled. So look at this. 36 minus 37. So difference is 1. And because of that, 1 is written here. So this n must be such a number which is at a difference of 3. So n must be such a number which is at a difference of 3. Now 37 is greater than 36. And it lies between 36 and n. So if it is greater than 36, it must be less than n. So n is actually 3 more than 37. So n should be equal to 40. 3 more than 37. Because a difference of 3 have to be maintained here. So n comes out to be equal to 40. So what you are trying to say is that in alloy B, total parts 96. Out of those 96 parts, 40 parts are of copper. That's why you can easily say that how many parts were of zinc. So zinc, remaining portion must be of zinc, 56 must be of zinc. So we have to find the ratio of copper and zinc in alloy B. So ratio 40 is to 56. So both are divisible by 8. So 5 is to 7. Let's see this one. Two alloys A and B weigh 10 kg each. So two alloys A and B, weight is 10 kg each. What else? The percentage of copper in A and B are 80% and 60% respectively. So percentage of copper here is 80% copper and this one 60% copper. Now what you have done? 2 kg is removed from each of the alloy A and B. So 2 kg from this one is removed and 2 kg from this one is also removed. The portion removed from A is added to B. So what you are removing from A is getting added to B, and what you are removing from B is getting added to A. What is the percentage point difference in the copper concentration of the two alloys? So good question. So this is the initial condition. Initially you haven't cut it. So let's see. So after having replaced the portions, you can visualize the alloys in this way. So 8 kgs of original, or you can say 8 kgs of A and 2 kgs of B. So this is 2 kgs of B. The second alloy has changed in this manner. So 8 kgs of B and 2 kgs of A. Now we know that A contains 80% copper and B contains 60% copper. So the weight is still 10 kg because you have taken 2 from here, but you have replaced it with another 2 kg. So the weight for both the alloys is still 10 kg, 10 kg each. Now let's find the quantity of copper. So this 2 kg is of B. So this 2 kg contains 60% copper and this 8 kg contains 80% copper. So copper content here, so A 2 kg, 60% of 2, 60% of 2 kgs plus 80% of 8 kgs. And what is the copper content here? Here the copper content, so this is 2 kg from A. So this contains 80% copper and this contains 60% copper. So similarly, copper content here will be 80% of 2 kgs plus 60% of 8 kgs. So let's solve this copper content. So 6 into 2, so 1.2 plus 6.4, so that is equal to total of 7.6 kgs of copper. So which means 76%, because total weight is 10 kg, so 76% copper. Here 80% of 2 kg, so 1.6 plus 60% of 8 kg, so that is 4.8. So 4.8 plus 1.6, so this comes out to be 6.4. So 6.4 kg means 6.4 kgs out of a total of 10 kg, so that is equal to 64%. Question is, what is the percentage point difference? So after having done so, what is the percentage point difference? So after you have exchanged, so after exchanging, so in this one the copper percentage was 76%, whereas in the other one it is 64%. So they are asking the difference of these two percentages. So percentage point difference, 76% minus 64%, so this comes out to be equal to 12%. So let's have a look at this question. 100 kgs of an alloy of tin and lead in the ratio 1:3 is mixed with X kgs of an alloy of tin and lead in the ratio 3:2. If the overall alloy should contain between 40% and 50% tin, what is the range of values X can take? What is the meaning of this question? So you have two types of alloy. So one alloy 100 kgs in which the ratio of tin and lead is 1:3. So let's see what do we know. So we have 100 kgs of alloy A. So first name them. There is alloy A, there is alloy B. So we have 100 kgs of alloy A. So this is known. The ratio of tin and lead is 1:3. So what is the percentage of tin? Percentage of tin in alloy A. So 1 part out of 4 parts, 1 plus 3, 4. So percentage of tin in alloy A is 25%. So you can say that this alloy contains 25% tin. What do we know about alloy B? So 100 kgs of alloy, so this already decoded, is mixed with X kgs of an alloy of tin and lead in the ratio 3:2. So percentage of tin in alloy B, so 3 part out of 5 parts, so 3 by 5. So that is equal to 60%. So the second alloy contains 60% tin. So you are using X kgs of this alloy. What is the question? Question is what should be the value of X? What should be the value of X if you want that upon mixing these two alloys, the final concentration of tin should lie between 40% to 50%. So you have to solve two extreme cases. So first you have to solve this, that in what ratio are you going to mix this, because this is the range in which you want to keep the final concentration. So let's solve for both the extreme values. Let's solve for this first. So let's use the crisscross method. So you will immediately get the ratio. So 25 and 40, what is the difference? Difference is 15. So what is the difference of 40 and 60? So that is 20. So if you try to reach this extreme, then as per the given data, the ratio should be 20 and 15. So 20 by 15 should be exactly equal to 100 by x ratio. So from here, x comes out to be equal to 75. So x will be equal to 75 if you try to reach this extreme. So for 40%, one boundary condition is x is equal to 75. Now let's solve for another boundary condition. The other boundary condition is 50%. So instead of 40, now let's make it 50 and solve. So one boundary 75. Let's find out the other boundary. So this time we are going to assume that the resultant is containing 50% tin, 50%. So let's solve for 50% now. So now we expect 50% tin in the resultant. So let's see. Now let's use the crisscross method. So difference between 25 and 50. So this is 25. Difference between 50 and 60. So this is 10. So this is the ratio. Ratio of 10 by 25 should be exactly equal to 100 by x. So x comes out to be 250. So the other extreme for reaching this boundary condition, x comes out to be 250. So two extreme cases. X can lie anywhere between 75 to 250. So let's see the option 75 to 250. Anywhere between 75 to 250. Now let's see this one. Two alloys of aluminium have different percentages of aluminium in them. The first one weighs 8 kgs. So let's call the alloy A and B. So alloy A is of 8 kg and the second one weighs 16 kg. The second alloy is of 16 kgs. One piece each of equal weight was cut off from both the alloys, and the first piece was alloyed with the second alloy and the second piece alloyed with the first one. As a result, the percentage of aluminium became the same in the resulting two new alloys. What was the weight of each cut off piece? So very good question. So we have no idea what is the percentage, what is the actual or initial percentage concentration of aluminium. Still they want us to solve this question. That means the answer is independent of the initial concentration of aluminium. Fine. So for the sake of simplicity, you can assume that this was 100% aluminium, this was 0% aluminium, because answer does not depend on the initial values. Nowhere initial value is given, still we have to solve this. That means answer does not depend on the initial concentration of aluminium. So to keep mathematics simple, you can assume that this was entirely aluminium and this was 0% aluminium. Now what you have done? You have taken equal weight from this. That means you cut out x kgs from here, you join that here, and x kgs from here and join it here. So after joining x kgs of B and 8 minus x kgs of original. And for the second one, 16 minus x kgs of original and x kgs of what have been replaced. Now this is 100% aluminium. So 100%, here 0%, here 100% aluminium, and this part 0% aluminium. What is the question? The percentage of aluminium becomes the same. Now let's calculate. So what is the content, aluminium content? So aluminium content. So 8 minus x, what is the total weight? Total weight is 8. So this is the percentage of aluminium. If you calculate, this is the percentage of aluminium finally that you are going to observe here. What is the final content of aluminium that you are going to get here? X out of 16. So x out of 16, because entire 100% of x is aluminium. So x by 16 into 100%, and both these percentages have to be equal. So you can say 8 minus x upon 8 is equal to x by 16. So this 8 and 16 will cancel. So from here 16 minus 2x is equal to x. So 3x is equal to 16, which means x is equal to 5.33 kgs. So here we have used the concept of dummy values because initial data is not given. Still we have been asked to solve this question. That means it is independent of the initial concentration.